In this SPSS tutorial, what we're going to focus on is correlation. Again, realizing correlation is going to give you some idea of the association between two variables. If you go up to your Analyze, we're going to go down to Correlate. Again, this is nice, it tells you where to go. From Correlate, we're going to go over to Bivariate correlation. What a bivariate correlation is compared to the partial or distance is that the bivariate's really going to look mainly at two variables. So while we might put multiple variables in the model, it's only ever going to correlate two variables at a time. So go ahead there. Again, we talked a little bit about the idea of certain variables. We want to really have meaningful correlation, so our continuous variables are going to make a lot of sense. When we talk about our nominal and our ordinal variables, then we get a little bit more concerned about the way in which we go about interpreting them. So for right now, let's take our continuous variables, the age of respondent, number of years in the profession, and your respondent's income, and move them over. And then we'll also add in sex of the respondent. Okay? What we really want to focus on here is our Pearson correlation. This is going to be our R coefficient. There's going to be a two-tailed test, and we want to make sure that the computer flags the significant correlations. Why not let it work for us, right? So go ahead and click OK. And you can see we have the output that gives us that nice diagonal line. If you remember in the lecture, what we were talking about was this mirror image of each other. So age of respondent is going to equal 1. Well, age of respondent and number of years in profession, and then the age of the respondent and the number of years in profession, these are going to be your same, let's go back here, these are going to be your same cells. The same thing goes here. Number of respondents, income in US dollars, and age of respondent, number of respondents. So you sort of have a mirror image on either side. Imagine taking a piece of paper and folding it diagonally. That's what we're looking at when we have this correlation matrix. So what I want to focus on is taking this diagonal. So we have a perfect correlation of 1 between the two variable and itself. And I'm just going to look below the ones here just to make it easier. What you'll see is we have basically no significant correlations. We have one that's actually presenting as a negative correlation, but it's not significant. Just to interpret this a little, you have your Pearson correlation, your significance of that correlation, and what this basically is the correlation coefficient between age of respondent and number of years in the profession is going to be 0.178 with a significance of 0.345. Again, not significant. So if that were significant, what we would say is that there is a positive correlation, and it's a relatively weak one. Let's move down here to number of years in profession and gender. What this is really looking at, because it's a negative, were it to be significant, it would tell us that, I guess one thing I didn't mention is the way sex of respondent is coded is 1 is male, 2 is female. So it's going to read what the number 1, the code of 1. So what this is saying is that males have fewer years in the profession than females, were that to be significant, but it's not. So it's a very simple procedure, a very useful piece of information when we find things that are significant, but as is the case in most research, we don't always find what we think we're going to find. So while there's nothing significant here, it shows you the pretty simple procedure that you would have to go through in order to calculate a correlation matrix. If you have any questions, make sure you ask one of your faculty members, and otherwise we will move on to our regression.